I went to DockerCon this year, and one of the messages out of the keynotes was, this is definitely going to be the year of Docker in production. And I thought, okay, that's kind of cool. I mean, my last year has been the year of Docker in production for me, for my company. I've been at Drama Fever for about a year now, and we've been running Docker in production since before I got there. So it was kind of cool to hear that validation that a lot of companies are thinking about or trying to move towards what we're doing now. Which means, hey, we can tell the story of what we're doing now, give you an outline of, so what I'm going to do is I'm going to outline our use case, and then talk about the various things that we've found that we had to pay attention to, and the ones that we found weren't such a big deal for us, even if people on the internet think they are. Your mileage may vary. Your business case is almost certainly different from ours. But anyway, so who am I? Why am I up here talking to you? My name is Bridget Krumhout, and I live in Minneapolis. I am an operations engineer at a company called Drama Fever. We're a streaming video site, much like Netflix, if Netflix were much smaller and mostly Korean soap opera. Let's see, I also co-host a podcast called Arrested DevOps, and I'm also part of the shadowy cabal that brings you DevOps days. Not actually shadowy, but we are a global group of people, and if you're interested in having a DevOps days event in your town, please talk to me, because we would love to have more. We're having more all the time. So enough about me, because let's talk about our use case for Docker in production. So as I said, we've been running Docker in production for a while now. We started running it in production when it was at version 0.6 point something back in October 2013. And at this point, you're thinking, wow, these people are not afraid of things. Well, that's what I thought, which is why I decided to go work with them in mid-2014, because I thought this would be pretty fun. And shout out to Tim Gross, who was the first ops person at Drama Fever, who had the idea of, hey, let's actually containerize our entire request path. What could go wrong? Spoiler alert, not too many things. It's actually worked out pretty well. And also, if you've seen talks from me before, you're wondering at this point when I learned how to use Photoshop. Yet no. Many thanks to Dave Yoon on our design team, who looked at my slides and said, I could probably help you with that. Because yes, I am an ops, which means if I design something, it would probably look like NetHack. Yeah, we stream international content, but because our entire website is run on container images, it was actually fairly easy for us to stand up a couple more sites. So we also run a couple of sites for AMC. We run the Sundance documentary site, and we run a horror site called Shudder. The interesting thing about these two other sites is that we're actually running them in production with the exact same Docker images that we're using for this streaming international television site. We just inject in different environment variables and stand them up on a different EC2 stack. But the fact that we were using Docker made it much easier to expand that section of our business. So this is a scale track here at OSCON, and we're talking about scale, and we'll talk about the scale of what we're running DramaFever.com particularly on, or at. But also the ability to scale horizontally out and run more sites is something Docker has really enabled for us. So for the DramaFever.com site, we have the kind of usage pattern you would expect for a site where most of the users are in the United States, despite the fact that it's mostly Asian television. We subtitle it in English, Spanish, and Portuguese. Most of our audience is 40% of our audience, I think, is white women 18 to 35, and another 30% is Latina women, same age range. So we subtitle it and offer it in the US and Latin America, which means that we have the daily cycle of viewing that you would expect, kind of a Netflix-style graph, except that we never actually go down to nothing. We still actually have traffic all the time. So again, it's we burst a lot of traffic, and then we subside, and then we just do it again the next day. And also the scale of the traffic that's hitting our endpoints, because of the way that we're offering this television streaming on not just streaming video on the web, but also native devices, we actually are offering API endpoints that all sorts of native clients are hitting. So that previous graph had a little bit of this scaling pattern. This is actually directly out of graphite, so it's much less pretty, but it's very real. And it's just a graph of groups of EC2 instances coming into and going out of one of our load balancers. So, and it's important to realize, I think, that the video stuff is actually on the edge. Like, that's actually being served by Akamai. But like, all of our endpoints are answering all of the calls, to where is someone and they're watching, or are they logging in? Are they a premium user? That sort of thing. Our architecture, because our site has been around since 2009, I think, like many sites that started in 2009, we started as a Python Django app. So I think that's interesting from the point of view of Dockerizing, because we Dockerized that. It's easy to say, oh, and we have our Go microservices running inside containers because, greenfield. But there's some actual brownfield stuff going on here, because we took our legacy infrastructure and moved it inside containers. Because of, and I'll show you in our build process, some of the benefits to us of that. Another important point here is that our state is not served on, or does not stay on the instances, because, as I mentioned before, we have very ephemeral infrastructure in most of our request path. I think the average lifespan of our typical EC2 instance is under 24 hours. It might be 18 hours tops. So we don't store the state on the instances themselves. We store it in Amazon managed data stores, whether it be Redis or Elasticache, Redis or Memcache in Elasticache, or DynamoDB or RDS, MySQL, depending on what the data is. But I think that's kind of important too, because people ask, well, wait, what about your data? And it's we're not really doing that part in containers because it's not necessary for our use case. Again, your use case almost certainly will vary. And then the other thing that's kind of interesting about this is, because we've been doing this since well before there was any of the Mesos, Marathon, Kubernetes, Swarm machine, any of the stuff that's coming along now, even console etcd, whatever, we're actually doing our discovery, such as it may be, just through Nginx routing. So Nginx points stuff at the ELB that has that microservice. I think that's, even though that's not the latest, most exciting hotness, I think that's kind of interesting to consider if you're thinking about putting containers into your infrastructure and you already have routing like that. This is kind of minimum viable Docker in production. This is possible to do without necessarily learning about and then testing and implementing every single thing that exists in the Docker ecosystem. Because that's frankly kind of intimidating. There's lots of it. And there's stuff you can start to do without even doing any of that, because we are. So I think a lot of people's why they should start using Docker story starts with their development infrastructure, and that makes a lot of sense. The benefits that you get in development, I think, are pretty well known at this point. For us, we get a lot of those same benefits in production, because the repeatability, the consistency, the atomic deploys, having that kind of certainty that what you're trying to troubleshoot is exactly what's in prod, because it's the same image, is really valuable for trying to track down those gnarly problems that you always run into when you're trying to operate stuff under a real workload. So it's nice to be able, especially if you've been in a scenario where you have to test in prod, because that's the only place you can actually replicate whatever it is that's going on. That still might happen, but at least we do have ways to peel stuff out of prod and eliminate a couple of those variables, maybe even the real traffic variable, in order to manage that. So in our development infrastructure, where we started out was where I think a lot of people may have started out when they've thought about moving to Docker. And the main reason that we needed to move away from using Vagrant there was because it just took too long for people to get a new an updated Vagrant box, which, developers want to develop. They don't want to be constantly working on their development environment, which means people would end up not updating their Vagrant box, which was sort of a problem. And, led to the kind of, conflicts down the road that you can imagine. So it was basically being able to do a Docker pull, Docker run way faster, right? And so, we started out using boot to Docker, and we ran into an issue because at the time, boot to Docker did not support the kind of volume mounting that we needed, because we wanted people to be able to have the checked out code that they have been working on and mount it right into the container and use it. One of the great things about this being an open source project, of course, is that we were able to fork boot to Docker at that point, because mainline, there were some discussions, but mainline wasn't ready to have that sort of volume handling in the project. But hey, open code out there. My boss, Tim Gross, just forked it, and we just kept working, which was, we eventually, with boot to Docker 1.3, were able to go back to mainline because they then supported that. But it's pretty valuable to not let that sort of obstacle stop your progress. And then we are actually, even though obviously a dev could do a Docker build anytime they want, we are actually building all of our images on Jenkins. So they can pull down the image that everyone else is using for development, as well as making their own, which is pretty powerful. And also, this is kind of a consistency of the build pipeline thing, because I think that there's also this idea that Docker is this magical universe where the devs do a Docker build on their laptop, ... production. And it's like, you could do that, but then I'm going to take your laptop because that's part of our important deploy process now. So it's like, we probably don't want to do that. But again, this makes for a lot more of a repeatable development cycle. Okay, so that's the Docker in development, that's fine. And when this talk is actually not going to go into a lot of and then this is how you do a Docker thing. Because I think that what I'm trying to do is contextualize it for you and say that, all right, Docker by itself is a thing that everyone thinks that they want to check out. But like when you put Docker in the ecosystem that you're actually working in, whatever your business case is, you may find that there's things you're not going to be able to do exactly the way every tutorial or front page of Hacker News or whatever tells you to do. So I'm going to talk a little bit about how we've actually used it. And like specifically the places that we've found that we had to pay attention to. So the first one would be the registry. So the Docker team is putting a lot of work into the Docker Hub, and there's even private registries on there now and all sorts of things. When we started doing this, there were no private registries on Docker Hub. So that was a non-starter for us right there, because there's plenty of things in our image, like our source code that parts of it are not open source because it's in parts of it, like we have, actual like configuration settings and things. We probably don't need, I don't know, like whatever else that's in those images doesn't necessarily need to be out on Docker Hub. However, we found that because of the auto-scaling that I mentioned earlier, when about 20 or 30 instances scaled up at the same time, and I'll try to do a Docker pull from the Docker registry we originally started running, it was kind of catastrophically failed and fell over and stopped responding, and we couldn't launch more EC2 instances and get them to be running the Docker containers that they needed to be, which was a problem. And so we could have solved this problem by building out a more robust, putting a bunch of resources into scaling up our Docker registry internally. But what turned out to make a lot more sense for us is to run a host local registry. And Tim has actually written a pretty good blog post about this. These slides are already online. Again, this really feels like deja vu because I talked about this yesterday. So hey, you don't have to wait, unlike the people yesterday. The slides are already online. So you can go check out this blog post, and it goes into a little bit more detail about the host local registry. But the TLDR on that is take the registry container and just run it everywhere. It's super lightweight. It's really not going to take away resources from the other stuff you're trying to run. And it's pretty handy to not worry. If you're trying to scale, it's handy to not worry about whether or not your registry is going to be able to handle the stampeding herd. And we also are using an S3-backed registry, and a little bit more about how we're starting that up. So we actually, after we went to, I think it was 1.3, we started needing to say we're not using SSL with this, because again, the registry is local. So if something is, in the middle of you talking to localhost, you probably have other problems. And so it's yeah, of course, SSLing all things is great, but when we're talking to localhost, possibly we're not as worried about that. The Docker option that we set there for, again, just when Docker itself is starting, is we make sure to use, and again, in EC2, we make sure to use the ephemeral disk for the Docker root, because these are short-lived instances anyway, and the Docker root can get kind of big depending on how big your images are. And having your instance have disk fill up because of Docker is something that happened to us. So we started making that less of an issue. And then having either, if it's on OS X, because of the way they changed the way the host-only networking works, so we actually need to use a different IP, not 127.0.0.1 anymore. But there's plenty of stuff online and also in that blog post that I linked to that goes into more detail about this. But this is the configuration settings that worked for us. And then for starting the registry itself, so we use Upstart, which is used as, it's a typical Linux init system. We're not going to get into the init system wars of like 2015 or whatever. Yes, systemd is both a floor wax and a dessert topping. It's like we can move on from that. But for our purposes here, like using Upstart jobs means it just gives it just enough management that the stuff will probably start and will hopefully restart if it fails. We don't usually have the stuff fail, so it's not a huge issue. And this is one place that we're actually pulling a public registry image. We did actually grab our own copy of it and stick it on Docker Hub, because at one point, they did update the registry image and not change the tag, and it was broken, and everything was sadness and on fire. So it's like the scar tissue that you accumulate. Like, okay, we're never doing that again. It's like, it's why we all have to take off our shoes at airports. It's like, when something happens once. Then we're just running this like locally on port 5000 and mapping that port inside the container so that the registry process that's running is answering on the local host port 5000. And we're passing in an environment variable with a config file, which this is kind of a stripped down version of the important stuff in this config file. If you decide to run a registry and use S3 as your backing store, like you are going to have to give it Amazon credentials through one mechanism or another. This one works pretty well for us because we have the bucket permission set such that everything has read-only access to it, except, I mean, not the whole world, but everything with credentials has read-only access to it. Only the Jenkins server has write access. And that's important for us because I don't know about you, but if I come home from the bar and I'm like, Docker build, Docker push, and then everything is sadness. Like, we want to avoid that. So we don't want to we want to save ourselves from accidentally pushing an image that we weren't intending. So we just only let Jenkins do it. And we also, like on someone's laptop, we would actually also start the registry there. So they're running the same kind of registry locally, on their Mac or whatever, in order to hit that same S3 bucket and be able to do Docker pulls of all of our images that we build. One thing to keep in mind about S3, if you decide to do this, is S3 cares a lot about your clock sync, which you would think, okay, I mean, my Mac or whatever is always going to have the correct clock, right? Okay, so if your laptop goes to sleep, then VirtualBox, delightfully, will let the virtual machine, the boot to Docker virtual machine, go to sleep, and it will suspend the clock. And so then your clock will be massively off and wrong and terrible when your laptop wakes back up. This is still not a solved problem in the most recent VirtualBox as far as I am aware. Tell me if I am wrong there, because I would be really happy to be wrong there. But this is just kind of like the unvarnished reality of what we ended up doing, is just sticking that as an alias in every helper script. So okay, every time a dev does one of the pull or run commands that we've wrapped for them, it's like this will also run just to make sure that their boot to Docker clock is set up correctly. So back to those images. I know that people have kind of talked on the internets about how the Docker registry is full of all sorts of insecure images and blah, 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 and people pull them off the registry, off Docker Hub, and everything is terrifying. It's like, okay, well, you don't have to do that. I mean, you can, but we care a lot about the provenance of our images. We want to know what we're running, and we want it to be things we built. So we actually have Jenkins, our continuous integration server, build our images for us and push them to the aforementioned S3 bucket. We do weekly base builds I mentioned that we have that Python Django app, and so that one, getting all the wheels and all the dependencies, and Python wants everything in the entire universe and full Ubuntu and everything, getting all of that to build is going to take a while, right? And since we're doing these, our actual, day-to-day development environment builds, we're doing, on every commit or every 2 minutes or whatever, we actually don't want to have to do this every time, right? So we've peeled out a weekly base build. We have some of the integration tests just run every morning instead of running with every commit. This does kind of speed things up, and then you're kind of, if you've used Docker at all, you're thinking wait a minute, aren't you taking any advantage of the Docker cache? And it's yes and no, because again, we're doing a lot of builds off of our master branch with a new Git hash, and so we're kind of starting fresh because depending, again, that gets into the minutiae, and we can talk about that later. But like for our Python Django project, for example, as well as this is a good example, I guess, because we do this for all of the projects, is we'll do a speculative build. And for this one in particular, I don't go into a lot of detail here, though we do actually stand up, because we use RDS in production and dev and staging, but for Jenkins, we do stand up a MySQL container and load it with fixtures just so we can run all these tests. So just assume that this actually is running against, real tests against like prod adjacent data so that you can, of the right shape and sort anyway. But if all of our tests pass, then we can tag this as this is now officially the dev image and push it. So that kind of keeps things like pretty consistent. Again, people can build whatever images they want, but they can easily pull down the one that everyone else is currently using. And another thing that's been kind of helpful for us with that is in terms of actually shipping these, images, we found that obviously, like Python depends on everything in the entire universe, but we are breaking our Python monolith up into, I think we're up to like 6 or 8 Go microservices for things like video ingest and analytics and bookmarking and that sort of thing. And those, we don't even need to ship like, all we need is the runtime, right? So like we can just, we can use a container to build the image on Jenkins, and then the image is actually a lot smaller. We've had similar success with our Android APK. Like that's actually not dependent on someone's laptop anymore, which is kind of delightful. But then we end up this is an example of the Python Django image is weighing in there at almost a gig, whereas I don't know if you can read that from the back, but the micro image is 10 meg. So. And people have been doing stuff like that with BusyBox or whatever, some of the tiny core stuff. But from our point of view, we actually don't even want an OS there, right? So we start from scratch, and we just Docker add the Go binary that we need. And then you're thinking, well, wait a minute, what about libc? Your mileage may vary. It's going to depend entirely on the specific, the specific requirements of the Go binary that you're trying to run. But this is totally possible, which of course means when we're auto-scaling up, this one we use a lot with our bookmarking service. So say you're watching video and you pause it, you're watching it on your tablet and you pause it, and then you go and you open it on your browser, and you would very much like to resume more or less where you were. And so that is obviously sending a lot of traffic, and it's scaling pretty aggressively. So that's an example of some place that it's nice to have the Docker pull when the host instance spins up be really fast. Because all of those Jenkins builds does kind of bring us to a place where we should probably talk for a minute about storage drivers. And there's been a lot of improvements in this area, but it's still pretty buggy and questionable. And basically the TLDR on that is device mapper is just kind of terrible. Device mapper is sadness as a service. You should just avoid it. And this ended up breaking a lot of our Jenkins builds because we would have all of these containers spinning up and being destroyed, and our builds would break. What I ended up doing, well, first, being a sysadmin, I was well, first I'll be applying a Band-Aid to this until I figure out what the heck is going on. So okay, retry those builds. Well, that worked, but it was really annoying. So it's our Jenkins server, our Jenkins server is called Leroy Jenkins. I mean, I assume all of your Jenkins servers are called that, right? And it's we don't really want Leroy telling us all the time that, the build's broken. So I went and dug into the GitHub issues, and again, it's open source project for the win. The Docker maintainers are wonderful people, and there was lots of advice and ideas of how we could solve this. And what we ended up doing is switching back to AUFS. And this is because, again, we're using Ubuntu, and device mapper is terrible, and it's terrible on Ubuntu. AUFS still has some bugginess. It still has some of its own problems, and it did require kernel extras to actually have it be available on 14.04, but it's fine. It's probably fine. It's hey, at least our builds don't break all the time now. And, all right, that helps us. But the folks at Docker, I mean, if you ask them, there is actually which storage driver should I use .github.io, and if you go look at it, you'll see Michael Crosby telling you it should be overlay. Okay, I mean, yes, again, our version of the kernel. Your mileage may vary. We're probably going to be switching to overlay just because we do have AUFS issues. So that's the brief, not so brief aside about storage drivers. You do have to sort of care about that maybe more than you would want to, depending on your version of all of the things. And oh, something else to consider is like we do have all of those ephemeral instances, but we also have a lot of, not a lot, but we have a few instances like our Jenkins server, like our dev and QA servers that stick around for a while. And for those ones, you need to clean up containers, clean up images. You're looking at this and thinking, wow, that's kind of YOLO. It's not as YOLO as it looks because the default is not to delete anything that's actually running. So it's actually fine, it's probably fine. But this doesn't actually kill anything we don't want it to kill. But because we have all of those speculative builds that will call the container the name of the Git hash and then tag the resulting build if it passes all the tests, we do end up with some stuff that if a build fails or whatever, there can be containers and images, things tagged none that need to be cleaned up. So this is kind of useful for us. Okay, so our deploy process is actually pretty simple, and I feel like I don't necessarily need to go into a ton of detail about it, but I mentioned before we use Upstart, and we're in Amazon, and we're using load balancers. So literally all we have to do is, we use Fabric for this currently, but I mean, it's a step better than SSH in a for loop, right? But it's basically a bunch of Python that just says, hits Bodo and says, pull this stuff out of the load balancer and tell it that it should restart the Upstart job. And it does. And the instances are running with the new version of whatever has been tagged for prod. And you're thinking, well, where did the prod tags come from? Like right now we have like a QA process, and then we say this is a release candidate, and it's speeding up all the time, and it's also speeding up all the time in all of our microservices. So it's like I don't have a one solid answer, but basically like if we've tagged something for staging, it's passed all the smoke testing, and we tag it for prod, we want to push that out, but we also, because we can do this at any time of day and everything is auto-scaling all the time, we also want anything that's auto-scaling up to already know and have and grab the right one. And since there isn't, like our application doesn't live on our machine image, it always will pull down the current thing. So then you're wondering, okay, wait a minute, what about these machine images? And those, when I started working there, they were kind of one of those hand-hacked Snowflake server sort of things where sometimes you would hand-hack it together a little bit differently and then your logs would break until next time you rolled out a new AMI for your entire infrastructure. And like once you've lived through that, you're like, this is horrible, let's fix this. And so as it turns out, like we found for us that even though we already had Docker, Docker does not actually do all the things. Like Docker is fantastic for the things inside the container, and it doesn't really do anything for your host instances. And so if you would like to configure your host instances in any specific sort of way, whether you're changing some defaults in the kernel as to what your instances should be capable of scaling to, or if you're log shipping stuff, or if in our case we were actually we wanted to have different Upstart jobs on the different kinds of instance, and we were using a pretty convoluted mechanism and moving away from that, which I'll show you briefly, but moving away from that meant that we actually now have chef-defined templates, Packer building via Jenkins, and everything passing through source control. So like we're not actually doing like knife upload cookbook of anything. Like we check everything into source control. There's a Jenkins job that sends it to Chef server and also like builds the Packer images that we then have our auto-scaling groups use for like the new image. So we don't have to do this with every code push, which is good since those are getting more and more frequent. But we do this when fundamental things about the configuration of our host instances changes. And we were using, the reason we moved to that is because we were using the user data facility in Amazon's EC2 that allows you to put a whole bunch of bash, basically, to just execute when the instance starts. But I mentioned those two other sites that we brought online. So instead of just having like the Drama Fever stuff, we had dev and then QA and then prod and whatever, but then multiply that by 3, and then multiply that by the proliferation of microservices. And everything had its own, carefully, like slowly drifting away from each other user data. So like having an external source of truth that you're using to configure your host instances like prevents that from being a problem for us anymore. So we did have this sort of thing, and we replaced it with like a Chef client run and a Packer build. For a little while, we were trying to run Chef client like live on production instances, and the problem with that is that, again, if you're running at scale, we're using hosted Chef, and every once in a while, the API endpoint wouldn't respond, and we would just have a bunch of instances like launch and then be unhealthy in the autoscaling group. So part of the takeaway for us there was like eliminate or reduce any external points of failure that we possibly can, because if you do anything enough times, you will run into failures. So like every corner case that you can possibly imagine, you will hit at scale. And then the upstart config that we're using, like this is an example of starting Django. Like we'll have a script that will actually start all the things that need to happen in that container. So your container entry point, like, they always are like one process, and it's like, maybe. I mean, we have some stuff going on with HA proxy and other things, so we want to make sure to pass the right environment variables into this. And again, because we're using the same images for all sorts of different, sites. So this has been sort of useful in terms of, configuring that. And in terms of doing it with Chef, I'm just going to go through these kind of quickly. The slides are online, so you can look at the code in more detail later. But we're using a template for the upstart stuff. And we are passing in all of the things you would expect, including like the application name, because they may not all be the same. And we are hitting the local host for that instance so that we are getting the registry from where it needs to be and getting the Docker image. My coworker, Pete Shannon, actually wrote a lightweight resource provider that lets us set this up pretty easily. And this lets us define exactly how an instance is going to look, like pretty precisely and in a pretty repeatable manner. And again, we're launching containers on the instance, but we still need to have the host instance behave and not suffer from configuration drift. We are using Packer to define this, and if you decide to do that, the one thing I would tell you to do with that is obviously you put all of these variables in your configurations or whatever, in your templates or whatever it is you're using. But the stuff that HashiCorp tells you is the correct permission levels that it says Packer needs. I don't know about you, but I don't actually want something running on my Jenkins server to have the ability to terminate instances in production. I feel like that's a terrible idea. That's like YOLO engineering at its worst. It's we don't actually do that. We restrict all that stuff to the really destructive things. We restrict to only if it's the instances that Packer has launched itself, just because that's less terrifying. Okay, so now we have a whole bunch of golden images, and that is its own sort of problem. That it's you probably saw that coming, but it's better than it was, but it's not where we want to be. So we're looking at Mesos and Marathon right now, and we're probably going to something in the application container clustering space, because I think it'll help us with our utilization. It's going to change some of the ways that our auto-scaling works, because right now we can auto-scale pretty precisely for a specific class of service based on load that's hitting that. So, but on the other hand, we do have some things that spike really dramatically and then go back down. Like a notification that a new series is, available, and 60,000 people cared a lot that that series has a new episode available. That can put spikes in our notify microservice that go away faster than an EC2 instance would even launch. So I think container clustering is going to help us a lot with that. There are some changes we're going to have to make around service discovery for this to work. I feel like every Docker talk I go to has one of these container shipping container disaster pictures, and I always just kind of want to say no, not really. I mean, I feel like there's a lot of drama around oh no, and then containers, ... everything falls in the ocean, and it really doesn't. It's this. It's not magic, but it also isn't terrible. I mean, it actually makes our lives a lot easier. I feel like a lot less. For the last year, I've been a lot less stressed, and I've hardly ever gotten paged, which is, as an ops person, is pretty much the highest praise. And the couple of things that people get really hot under the collar about, that don't actually turn out to be a huge problem in our use case, we aren't using the containers to try to isolate anything from anything else on the host instance. So if you were trying to run a multi-tenancy thing that you let clients log into, and you were just using Docker to separate them, yeah, I don't know, that might be kind of terrifying. I would probably not recommend doing that currently. But for our use case, we control the provenance of our images, and we're not running arbitrary images off the internet, which, I mean, I don't know, how many of you are curl bashing? I hope you're not. So this turns out to be not as much of a worry as you would think. And the way we handle our logs, like in Docker 1.6, 1.7 or so, they've come out with some syslog driver stuff that looks pretty good, and so we may actually give that a shot. But the way we're handling our logs right now is we just mount them out of the container, and then we use nxlog to handle them, and we send them right to Logstash, and like it works perfectly fine. So that actually is not. People kind of go into this whole container monitoring, it's a whole thing, and it's like, I mean, for our needs, like actually not so much. It's not a huge problem. It works pretty well. And we didn't, I mean, this is a pretty bog standard monitoring and alerting setup, and there's nothing on here that says containers. The Graphite server and the Elk stack are actually running inside containers. But I was actually concerned about that at first, and I thought that there may be actual problems from it, and there really wasn't. And like, so we didn't need a significant difference in our monitoring and alerting just because we have Docker. Like, it doesn't really make a difference. It actually works just fine. And you're probably looking at these arrows and thinking, wait a minute, what the heck is that CloudWatch to Graphite? And that is sort of interesting, has nothing to do with Docker really, but you know how CloudWatch only gives you data for 2 weeks? So we have cron jobs that run on Graphite, on the Graphite server, that go and use Bodo to pull down the data from CloudWatch and shove it into Graphite so that we can keep it, so that we have the CloudWatch data for longer than 2 weeks. Because we like looking at data over time, because ops is a thing you do. And yeah, basically like my TLDR from this is, I think that there's a lot of, I'm not sure where we are in the Gartner hype cycle about Docker. I kind of feel like for a while at least, it kind of seemed like if you ran a Markov chain against the front page of Hacker News and made your technology decisions based on that, you'd probably be running Docker in production. And it's like, that's not how we made our decisions. I mean, it was pretty useful for our needs and for the ephemeral nature of our infrastructure to set it up like this. But that's not how we made our decisions, but I feel like all of the hype around it is kind of shrug, kind of unnecessary, because it's just another tool. We use it with a lot of normal tools. It works pretty well. There's some bugginess that the open source project maintainers like continue to work on and are pretty awesome. And so like, I actually recommend it. I mean, it's been really solid for us. Like, we have like a lot of requests per second and customers who watch the stuff religiously, possibly addictively. And like, if it didn't work for our business case, we would not be doing it. So yeah, that's kind of it actually works. And it's kind of super. And I'm not sure if there's hot air balloons, and Jerome is probably up in that hot air balloon somewhere. But I'm not sure about that, but it's actually pretty fun and way less stressful than and then we accidentally upgraded Ruby everywhere and everything broke. Like, that doesn't happen anymore, which is delightful. So yeah, basically, like, if this sounded interesting to you, since my company flew me here, I think I'm contractually obligated to tell you that we're hiring. And we're remote friendly, and our main office is in Manhattan and a tech office in Philly, but I live in Minneapolis. So, we use GitHub and Slack and all of the things. So if you like that sort of thing, you should probably talk to me. And I have no idea what time it is or if I have time for questions at all. I see someone raising a hand, and I don't know if that means that they have questions or not. I should probably just say thank you. So, thank you.